In this video, I'll talk about Apache Pig. Apache Pig is a scripting language that handles data engineering on Hadoop. It processes raw data with various operations such as load, filter, group, join, and store. Apache Pig consists of data flows. And when we talked about data flows, we mean that we talked about data processing tasks such as load, processing, store. The language is Pig Latin, which is a declarative language that defines data flow activities, specifying what needed, then you convert it to map-reduce jobs. The language is simple, easy, and makes map-reduce tasks easier and less coding to Java MapReduce. And it is used for batch processing because it takes some time to process in MapReduce and can be extended using user-defined functions. After the Pig statements are submitted, they are converted to MapReduce jobs to run on Hadoop cluster. Then the MapReduce jobs run and the result is returned from the MapReduce to the users. Because the jobs run in parallel, so it can process large amount of data in Hadoop cluster easily. Now let's talk about the Pig execution mode. First, we talked about the local mode, which runs on a single Java virtual machine. In order to enter this mode, you type in pig and then use the -x parameter and then local. In this local mode, Pig uses the local file system and it works with the local files on the Linux or Unix systems, and it does not use Hadoop and does not do MapReduce. And it is mainly used for development and for testing on small datasets. And once the scripts are ready, then they can be deployed in production on the Hadoop cluster. The other mode is the MapReduce mode. To run Pig in the MapReduce mode, you need access to the Hadoop cluster and the UDFs installation. And it uses the UDFs file system, and you need to copy files to UDFs for processing using the copy from local and copy to local parameter. Several steps are automatically implemented by Pig, and then the scripts are converted to MapReduce job and run on the cluster. And it is mainly used for production and on large datasets. Now let's talk about Pig shell. Grunt shell is for interactive execution. And it's just like shells in MySQL, Oracle, Hive, and etc. And users can type commands to run directly. And if you want to write Pig scripts, then save the files as .pig extension to run on the Grunt shell. And there are many editors that support Pig syntax for Pig development, such as highlighting and coloring. And those are, for example, Eclipse and Vim. This slide shows the simple data types such as int for integer, long for long integer, float, and double. Float is 32-bit floating point and double is 64-bit floating point. Char arrays is for storing string and byte array is for storing bytes, and this is the default, it's not specified. This slide shows the complex data types. The first type is field. Field is actually a piece of data similar as the database field, and it can be simple or complex data type. The next is tuple. Tuple is an ordered set of fields similar as a database rows. So in this example, we have a row or tuple with several fields. So 10 is like the customer ID and the name Amanda, and the address is stores Connecticut. The next complex type is bag. Bag is a collection of tuples. For example, between the curly brackets, we have two tuples, and each tuple has two fields. And next we have relation. Relation is actually a bag, or more exactly an outer bag, and similar as the database table. In the example, this relation has two tuples. And finally, a map is a set of key value pairs. For example, in this map, there are two key value pairs. In the first pair, the key is customer ID and the value is 10, separated by the pound sign. And the second key value pair is name, which is the key, and Amanda, which is the value. Nulls are supported in Pig and are used when there is no value in a field. Schema. A schema can be provided in the data load, and the name and the data type can be specified for each field. A field can be accessed using either the field name or the field position. The field name, for example, customer ID in the table customer. So if customer ID is the first field, then you can write, you can access to the field using the field position, for example, customer dot and then the dollar sign and 0. This slide shows the simple operators, and we have arithmetic operators, Boolean operators, casting operators to convert data type. For example, if we want to convert data type to integer, we have comparison operators, which are for matching patterns. Flatten operator, that is for changing the structure of tuples and bags. That nests tuples as well as bags. For example, if we have a tuple with this tuple is in the form of A, and then A, and then B and C, can be flattened into the form of A, B, and C. The null operators are is null and is not null, for checking if the value in a specific field is null or not null. And then the sign operators. Next, we talked about relational operators. The load operator loads data from the file system to a relation. Thus, this is the example. Load the file, and the file here is actually in header cluster, and it should be copied before you run this command, this statement. And here we assume that we run Pig in the map reduce mode, and otherwise if you run this in the local mode, then this can be the local path. And here we specify the separator, which is a comma in the CSV file. And in the schema, you can specify the field name and the data type for each field. The next is the filter operator. It filters a relation based on some conditions, then returns a relation with filtered tuples. In this example, Sales fact is filtered by store ID equal to 1 and then stored to store 1 sales. The group operator groups data based on some fields and then returns a bag of group elements and an inner bag of corresponding values. In this example, the relation store sales is filtered by store ID equal to 1 and then returns another relation to store 1 sales. And then the group operator group by customer ID and then returns a bag of group elements in sales fact group. Dump sales fact group will dump the data in sales fact group onto the screen. In the return bag, you will see something like this. The group is customer ID, and then in the inner bag, for example, for group 10114, you see all tuples belonging to this customer, 10114, and similarly for the customer 10160. The inner bag contains all the tuples belonging to that customer, and this is what you see in the shell. The Foreach operator goes through records and performs operations on individual or group data. In this example, the relation sales fact is grouped by store ID and returned into sales fact group. Then the Foreach operator goes through this bag, sales fact group, and for each record generate a group which is the store ID, and then sum of sales fact. Sales fact is the sales fact table, and then unit sales, which is the field. Basically, it gives the sum of unit sales for each group or for each store ID, and then dump all the data in store sales. Then what you see would be something like this, and there are more, but here we don't have enough space. And then the store operator stores a relation to a directory. For example, store sales into this directory, and then in the grunt shell you can run this command line to show the data in store sales. The join operator joins two relations based on a common field, just like a SQL join. So in this example, I use the load operator to load data from this CSV file, customer.csv, into a relation, namely customer. And then I use the join operator to join the two relations, sales fact and customer, by the common field, customer ID. If I dump the result using the dump sales customer join statement, then what I see would be something like this. So each tuple here contains information from both relations. So the red elements are actually the information from the sales table, and the green elements are actually the information from the customer table or the customer relation. There are the relational operators such as distinct that gets distinct tuples, order by that orders relations based on one or more fields, split that split a relation into two relations based on some conditions. Union that joins two relations like SQL union, and cross that joins two relations without join conditions. So a row in one relation is joined to every other row in the second relation. We have diagnostic operators just described that returns a schema of a relation. Dump that dumps or display result to the screen, and explain that displays execution plans for MapReduce jobs for statement. User-defined functions that are written in Java, Python, Scala can be used in Pig, and they provide more complex extension to Pig functions. User-defined functions are compiled into jar files and then registered to Pig for being used. In order to write and compile UDF in Java, we need Java libraries such as the Pig libraries. Here is the Pig jar and the Hadoop core jar files. This slide shows an example for the user-defined function. Here we have a package, namely dataproc, and we import from several libraries. The class name is getStatus, that stands eval func, which is a class in Pig. Exec takes input as a tuple and returns a string. If the input string is S, then it returns a more complete string, namely single, and if the input string is D, then it returns divorced, and if the input string is M, or actually any other case, it returns marriage. So after compiling, and we have a jar file, namely dataproc.jar, we copy the jar file, let's say to the directory home/cloudra/udf, and this is the local path on your Cloudra virtual machine. In Pig, if you want to use the class, you need to run this line. So register and then give it the jar path, then it register the jar file to Pig for use later. And here assume that the customer relation was loaded previously, then use Foreach to walk through each record and generate the customer ID, and then the marital status. And the marital status in originally is containing just the single letter like S, M, or D. So here you use the getStatus, which is the name of the class, and give it the original status. Then this would return the complete status, such as like marriage, single, or divorced, and then dump the data. So the result is in customer status, and then it's dumped to the screen. Dataflow is actually a collection of user-defined functions for working with large-scale data in Hadoop and Pig, and you can use a lot of functions in here, and you can download the file. You can either using this link or go to Google and search for Dataflow download. In order to use functions in Dataflow, you got to register Dataflow. So register and give it the path, the full path to the file name, to the file. In the next statement, the average of store sales in sales fact relation is computed. And in the next statement, the standard deviation of store sales is computed using the var function in data flow. And then the cross-join, this line actually add sales mean and sales standard deviation to every tuple. And then the next one walk through each record and generate the customer ID store sales as well as the normalized values for store sales in a separate field, and then dump everything in normalized sales to the screen. And here there is a note: if the Java version on Cloudera virtual machine is different, normally it's lower than the version on the machine that compiles the Java project, then in NetBeans, right click on the project and then select properties, and it will show you a dialog like this. And then change the Java platform. So normally, in my computer, normally I have a Java platform which is 1.8, and here I have to change it back to JDK 1.7, so that later on I will get the error, the passing version error, when Pig uses the UDF. Now let's talk a little bit about Hue. The Apache's Hadoop Hue UI can be used for high, Pig, and etc. You can use Hue directly in a VM, and if port forwarding was set, then you can just use it outside the VM using this link 127.0.0.1, and this is a port, and this basically is a local host. You can use localhost instead. And otherwise, if you use this in directly in the VM, then just use quickstart.cloudera, and then this is a port number, which is 8888. So you can use the Pig editor in Hue directly to submit Pig statements, or you can use Pig shell as we have shown previously.